So, hello everybody. My name is Balazs Varga, and I'm working at Allotropia company. And I would like to talk about LibreOffice WebAssembly, EMBind, and how to use the LibreOffice UNO programming API directly from JavaScript against LibreOffice running next to it in a web browser session. So let's talk about firstly about the LibreOffice WebAssembly generally. Can you hear me? It's better? Yes. Okay, so I will move a little bit closer. So the LibreOffice WebAssembly port is an Allotropia lead initiative to have LibreOffice ported to WebAssembly. With that, LibreOffice can be running natively and fully client-side in all modern web browser. It is built with the newest Emscripten version now, with the 3.1 version. Also works with the Qt framework as the UR or in headless mode, which I showed in last year here in the cool days. And it's also working with the Collabora Online, which was also ported to WebAssembly in the last years. So, but we had a better idea to having a direct interface on the browser enables wide range of applications. Also, because with that is not so overhead, like with other frameworks, for example, the Qt. Generally, about the EMBind is used to bind C++ functions and classes to JavaScript, so that the compiled code can be used in a natural way by normal JavaScript. EMBind also support calling JavaScript classes from C++, and EMBind support for binding most C++ constructs, including those introduced in C++ 11 and 14 as well. EMBind is, as I mentioned, is part of the Emscripten toolchain. EMBind was inspired by the Boost Python and uses a very similar approach for defining bindings. At the moment, there is no comprehensive EMBind performance testing, either against standard benchmarks or relative to web. The call overhead for simple functions has been measured at about 200 nanoseconds, as I know, while there is room for further optimizations for the EMBind. But so far, its performance in real-world applications has proved to be more than acceptable. So let's see an example in the code base. So the binding block defines a chain of member function call on the temporary class object. The same style is used in Boost Python. The function register the class, its constructor, the member function, the class function, and if they have the properties as well. The binding block binds the class and all its methods. As a rule, it should be binded only those items that are actually needed, as each binding increases the code size and it can cause slowness. Let's see another example. It's a simple get text UNO function from the X text range interface. The function registered also the class and its constructor, member functions, and class functions and property. Also, it's important that if C++ classes have virtual or abstract member functions, it's possible to override them in JavaScript because because JavaScript has no knowledge of the C++ table, EMBind needs a bit of glue code to convert C++ virtual function calls into JavaScript calls. Okay, in this example, you can see some EM-bind construction of UNO any types. Some of them was already EM-binded successfully already, and some of them was added in the last month by Stefan. For example, the sequence, structure exception, and the interface and enum UNO types as well. This is just a small part of the code. And here is a usage example through JavaScript of the current implementation. In the example, we create an empty document and insert the text into the first paragraph. First, we create UNO EM-bind module. Then we create the namespace, and then a text document, text cursor, and after that we can insert a text into the document. Here is another example. In this case, we change all the paragraph character color. First, we also create an UNO module, then iterate through on the existing text paragraphs and set a property value which contain random color in an UNO any type. Let's talk a little bit about the exceptions. We can already catch C++ exceptions from JavaScript, but the code exception is just a pointer to the exception with no operand type attached. After the introduction of tags to WebAssembly, EM-bind introduced some serious functions in the newer versions. I think in the mscript 3.1, they introduced this new get CPP exception tag or get CPP exception throw value functions, which can be useful for the UNO exceptions as well, which are not handled at the moment. And we didn't try it yet, but theoretically it should work with that, as I discussed with Stefan about that. That would be one of the next tasks around here. And also about the future plans is to make API more JavaScript compatible and EM-bind more UNO types and handling UNO exceptions as well, which would be very important. And yeah, thank you for your attention.